Hey everyone, welcome back to the Foundations in Pre-Calculus 10 videos. In this video, we're going to look at Lesson 2 from Chapter 6, which is talking about slopes of parallel and perpendicular lines. So two lines, or two linear relations, are said to be parallel if their slopes are exactly the same. So if we were to look at this example here, if we were to calculate the slope using that rate of change formula, we would find that our slope is negative 3 over 2 for our dark blue line, and it is the exact same for a light blue line. So you need to have the exact same number for your slope for each of those equations. So it doesn't matter what anything else is, as long as that slope is the same, you have parallel lines. And so just as a quick recap, remember that parallel lines means that at no point do those two lines intersect. No matter if you were to extend them on going up or down, forward or back, whatever direction they're moving, no matter how far you extended them, they would never intersect. So in order for that to happen when we're working with linear relations, is that we must have our slopes being exactly the same number. So when we're looking at perpendicular lines, here is, I guess we have the situation where your slopes must be what we call the negative reciprocals of each other. So negative just meaning one is positive, one is negative, and then reciprocal, if you guys recall, a reciprocal means that you take, you have a fraction and you flip it. It's 1 divided by that number. So say for example we were to have the number 3 over 4, the reciprocal of that is where you flip it. Your numerator becomes your denominator, and your denominator becomes your numerator. So then we get 4 over 3. So if we're taking the negative reciprocal, that would be negative 4 over 3 as your answer. One thing that's important is that if we had a whole number, say we just had the number 2, we could write this as a fraction as 2 over 1, and then we could take the reciprocal of that, which we get 1/2. So if we wanted that negative reciprocal, we'd have negative 1/2 there. Okay? So looking at our example here with our red and blue lines here, if we were to calculate the slope of each of those graphs or each of those lines, we would see that your blue line, this one going down from left to right here, this one here would have a negative 1 over 3 for your slope, whereas the red line would actually have a slope of positive 3. Now we can say that these two here are negative reciprocals because we have one that's positive or one that's negative and one that's positive, and then this is 1 over 3, and the reciprocal of 1 over 3 is 3 over 1, which is simply just 3. So here we have that negative reciprocal relationship, which means that they're perpendicular. And also, just as a quick recap, don't forget that perpendicular means that the two lines intersect at 90 degrees. Okay, so that's just the definition of perpendicular. So now we're going to take a look at an example from your notes, which is example number 2, where we're going to determine a slope given the slope of another line. So here we're going to determine the slope of a line that is perpendicular to a line that passes through G, which is negative 2 and 3, and H, which is 1 and negative 2. So here what we're doing is we're trying to find the slope of a line that is perpendicular, which means that we must take the negative reciprocal of whatever the slope of the line that passes through points G and through points H. So when this is the only type of information we're given about the line that it intersects or that it's being compared to, what we need to do is we have to figure out the slope of that line. And so to do that, we're going to use that rate of change equation where we have m is equal to y2 minus y1 over x2 minus x1. And then what I'm going to do is I'm just going to label our coordinates here just to make sure I get my coordinates in there properly into that equation so we don't have any errors. So this here is an x and y coordinate, and then we can let G be our first coordinate that we were given. So we can call this x1 and y1. Then we can go over to our second coordinate, and here we have an x and y pair, and this one here was our second coordinate, so we'll call that x2 and y2. My big point about labeling them is that this way we know exactly where each of those numbers belong in our formula, and so we don't get them mixed up and end up switching numbers when we shouldn't be. So then plugging our values into the equation, we have y2, which we have labeled here as -2, minus y1, which is positive 3. That's over x2, which is 1, minus x1, which is -2. So minus -2. Then simplifying each of that numerator and denominator, we have -2 minus 3 is -5. And then 1 minus -2 becomes positive 3. So this one here, we have a negative times a negative. So this is really just 1 plus 2. So this here is the slope of the first line that we're looking at. And so what we want to do is, in order to figure out this line, the slope of the other line, is we must take the negative reciprocal since it's perpendicular. So the slope of the other line is equal to the negative. So if it was negative before, it becomes positive. And then we flip our fraction. So if it was 5/3, that becomes positive 3/5. So just to recap, so remember with perpendicular lines, you take the negative reciprocal. So if this was already negative, then your answer becomes positive. If it was positive, it becomes negative. And then when you have that fraction, you just switch your numerator and your denominator to find that new slope. So that is everything here for this video. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.